geometric progression. In this, if I start off with series, which is 1, 2, 4, 8, 16, 32. I know one thing, that is, this is T1, T2, T3, T4, T5, and T6. So T7 should be 64. Now, what you see is in geometric progression, you have ratio to deal with. You have ratio. And how do you get ratio? Your term 2 divided by term 1 is also equal to term 3 divided by term 2 equal to term 4 divided by term 3. That means obviously you can have any term, but you need to divide it by term that is behind that. So the ratio for each terms will remain same. That means if I say that 2 divided by 1, we end up having what? 2. Even if we have 4 divided by 2, we will end up having 2. If we end up having 8 divided by 4, we will have ratio as what? 2. So the ratio will remain same in all circumstances whenever we do geometric progression. Now, we had formula in AP that was Tn is equal to A plus n minus 1 D. So we also have formula here as well, that is A, because obviously this is the first term, R n minus 1. A R n minus 1. Now, in this, your Tn represents value of nth term. Your A represents first value of series. Your R represents ratio. Your N specifically represents the nth term that is required. Now, if I say that I have been given this, similarly, I can easily use this formula, considering that Tn is equal to A R n minus 1. I can use it for term 6. My first value is 1. My first value is 1. The ratio that we calculated for the series, that was 2. 6 minus 1, because n is 6, because it requires me to give the answer for T6. So T6 is equal to 1, 2 to the power 5. And 2 to the power 5 means 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2, which means 32 will be the answer for any value that is 2 to the power 5. Following on, if we see, so can we say that if we require the value of the 7th term, if we require the value of the 7th term, so we can easily do that. The first term is obviously 1 in the given series. Your first term value will always change according to the series that you have, right? Your R is 2, and this will be 7 minus 1. So T7 will be 2 to the power 6, and T7 should be what? 64. So this is normally in terms of the formula that is given, that is Tn is equal to A R n minus 1, that we normally use. Why are we using this? Because in the given question, there can be requirement of you to calculate, let's say, 15th term value. You to require 15th term value. For this, you need to take out your calculators to calculate is equal to A R. This should be 15 minus 1. And you can always substitute the first value, which was obviously 1, and the value of R was what? 2. So Can we say term 15 is equal to 2 to the power 14? And 2 to the power 14 is 16384. So the value of the 15th term in the geometrical progression is 16384. Similarly, when we did the GP, when we did AP, you would understand that in the given circumstances, you were creating the formula that is Tn is equal to ARn minus 1. In the AP, what you used to do is, for suppose if there was 10th term, you used to say it is A plus 9D. If it was 15th term, you used to say it was A plus 14D. So here is a similar case to AP, that if there is first term, AR1 minus 1, which means this should be T1 is AR to the power 0. Anything to the power 0 is 1. Anything to the power 0 is. So T1 becomes what? A. Similarly, if we have T2, that means AR2 minus 1, which is T2 is equal to AR1. So T2 value can directly be written as AR. Similarly, T3, if we say AR3 minus 1, so this should be T2 should be T3 should be AR square. Similarly, T4 should be AR4 minus 1, which means T4 should be AR cube. Now, there is a pattern that is going on. There's a pattern that is going on. So that means if I have 10th term, I can directly say, okay, the formula should be AR to the power 9. If it is 15th term, I can directly say AR to the power 14. Now, in the given question series, let's take two terms. Let's calculate the value of A and the value of R directly. Let's say that we have T2 is equal to, or we can say T3 is equal to 4. And let's say T5 is equal to 16. T3 is equal to 4 and T5 is equal to 16. Find the value of A and R. Now, such questions are normally given in your GP. Such questions are normally given in the geometrical progression. That means the examiner tests these kind of question in the given structured question. That means you need to understand it through the words of the examiner. So can I say particularly that T3 is equal to what? 4. I can use it as AR square is equal to 4. T5 is equal to 16. I can use it as AR to the power 4 is equal to 16. So obviously the power will be 1 less than the term that is given. If the term is 3, the power will become square. If the term is 5, the power will become what? 4. So in this regard, if you notice that I can easily write down, I can easily do the simultaneous equation from the method using simultaneous equation. So A is equal to 4 upon R square can be used. And I can easily use 4 upon R square in place of A. And R to the power 4 should be equal to what? 16. If we cancel square with 4, we are left with what? 2. So can we say that R square is equal to 16 divided by 4 will be 4. But R should be under root 4, which means you will have ratio in plus and minus. But in this regard, if I say we will be using 2, because normally in such condition, the examiner will tell you that your ratio is positive or the ratio is negative. Now, if I say that A is equal to 4 upon 2 square, so that means 4 upon 4, so that means A will be what? 1. So your value of A was 1 and the value of ratio was what? 2. I hope that I have made myself very clear to the... Okay. Now, since we understood the term pattern, we understood that there can be a simultaneous equation in the question. The examiner can also test us with sum. But now sum can be used in two different ways. That means sum is for r greater than 1. Sum can be for r less than 1. For r greater than 1, it is an increasing series. For r greater than 1, it is an increasing series. For r less than 1, it is a decreasing series. It is a decreasing series. Which means if I say increasing pattern was 1, 2, 4, 8, 16, 32. If I write down decreasing series, 32, 16, 8, 4, 2, and 1. So the pattern will change. Even the ratio can be changed because of the increasing decrease. For this, the ratio was, let's say 16 upon 8. So ratio was what? 2. And here, if I say the ratio is 8 upon 16. So the ratio here will be what? Half. So the ratio for both these series will be different, because obviously to find out the ratio, you need to have the any term and divide it by the term value behind it. So can I say that 16 upon 8 is 2, but in the decreasing series, similarly to this, 8 upon 16 will be what? 1 upon 2. So if I want to have sum, the sum formula for r greater than 1 will be a rn minus 1 upon r minus 1. The sum formula will be r to the power n minus 1 upon r minus 1. This is normally used for increasing series. This is normally used for your increasing series. Similarly, for sum for decreasing series, I can use it as a 1 minus r to the power n upon 1 minus r. Why do we change the formula? If you note that if r is less than 1 and we keep r first in the denominator, then obviously we will have the value in the negative. So to avoid that, we change the places. Nothing else. The formula will remain same according to the given perspective. Now you need to understand this thing, that if you need to have the sum for 6 terms, let's say how many terms we had? We had 1, 2, 3, 4, 5, 6. So can I say sum of 6 terms can be T1 plus T2 plus T3 plus T4 plus T5 plus T6. So that means sum of 6 term is 1 plus 2 plus 4 plus 8 plus 16 plus 32. The sum will be S is equal to 6. 32 plus 16 is 48. 48 plus 8 is 56, 60, 63. The sum of 6 terms will be 63. If we calculate it through the formula Fn, your value of the first term was a, obviously r n minus 1 upon r minus 1. This was the formula, right? So can we say that S to n is 6, r a is 1, your r was 2, 6 minus 1 upon 2 minus 1. S6 is equal to 1. 2 to the power 6 is directly what? 64. Minus 1 upon 2 minus 1. 2 minus 1 is 1 in the denominator. 64 minus 1 becomes what? So 63 will be the sum. Similar case, let's follow the same pattern here as well. If I say that term, I need to have sum of 6 terms, but here the a is 32 and r is equal to what? 1 upon 2. We calculated r, right? But what we need to understand is the formula is a bit different. So S6 is equal to, considering a as 32, 1 minus half to the power 6 upon 1 minus half. So can I say that S6 is equal to 32 1 minus half to the power 6 upon 0.5 upon 0.5. If we calculate 0.5 to the power 6, if we calculate 0.5 to the power 6, what is the answer that we get? We get 1 upon 64. And 1 minus 1 upon 64 multiplied by 32. What do we have? Can I have the total number, total sum of the given expression? What will be the total sum? Since the value is 32, we started off from 32. The answer is 63. In this case, if you agree to one thing, now you need to understand a concept behind this. You need to understand a concept behind this. How many terms we had? 32, 16, 8, 4, 2, 1. We had 6 terms in the decreasing series. Okay? We had 6 terms in the increasing series. Both we had 6 terms, and obviously we had 63 for both the sum. 63 for both. But if we have one thing, and that is I increase the number of terms in the decreasing series. I increase the number of terms in the decreasing series. That means let's work on decreasing series a bit. Decreasing series, which means R is less than 1, right? R is less than 1. Can we say that we started off from 32, we went to what? 16, 8, 4, 2, and 1. If we obviously multiply by half, we multiply the next term by half. So what we will have is 1 upon 2. Then we will have 1 upon 4. Then we will have 1 upon 8, 1 upon 16, 1 upon 32, 1 upon 64, 1 upon 128. I think that is enough to make sure that you understand the concept. Now, what you need to understand is from here till the 6th term, you will have sum of what? 63. But from this point till the 1 upon 128 or any further terms, you will have sum which will be equal to 1. You will have sum which is equal to 1. That means for any sum, for any term, for the further values, for the further terms than 6, you will end up having what? Your sum as 64. Let's just calculate this. And we need to understand why is this happening. Let's calculate. Sn. Number 1, is it a decreasing series? So R less than 1, A 1 minus R to the power n upon 1 minus R. Then let's take sum of 15th term. Sum of how many terms? 15. Your first value was 32. 1 minus R is 1 upon 2. And the n should be what? 15. We do not subtract 1 from this because it is the subtraction takes place only in the term. Here the entire term will come. And this should be 1 minus half here as well, which means 1 minus half means 0.5. Can you calculate can you calculate this using calculator, please? 1 minus half to the power 15 multiplied by 32. 63.99. So that means I can say that the sum was equal to what? 64. Now let's further do this. Since I need you to understand the concept. Let's take sum of 50 terms. 32, 1 minus half, 50, and this should be 1 minus half as well. So for sum of 50 terms, we have 64 again. While using the calculator, you have calculated this. Even, let's say, sum of 100 terms will still be 64. Why is this happening? Because in decreasing series, whenever we have a decreasing series, there's a point where we will have sum of infinity. We will have sum of infinity. This will tell us the maximum limit to the sum in the decreasing series, because there will be a time if your number, your least number, positive least number, when divided multiplied by the ratio, you will end up dividing the same number over and over and over again. Similarly here, we divided 1, we divided by 1 upon 2, we divided 1 by 4, we divided 1 by 8, we divided 1 by 16, we divided 1. Actually, we are dividing that one particularly one, that value that is in. So can we say that to calculate that sum directly, obviously we will not be following this again and again to calculate the sum of infinity to the maximum value. So what we're going to do is, we will have the formula for sum of infinity, and the formula is A upon 1 minus R. A upon 1 minus R. Your A was 32, 1 minus half. So directly I will have sum of infinity as what? 64. So sum of infinity is very important. It is only applied when R is less than 1. In increasing series, if you know that it will keep on raising the value. So sum of infinity cannot be applied. But in the decreasing series, your sum of infinity will be applied. Your decreasing series is also known as convergent series, and your increasing series is also known as divergent series. So these are the two words that can be used by the examiner through the question. If the examiner wants, they can directly say, okay, you have a convergent series or you have a divergent series. One thing else, if in the ratio, if there is an increasing ratio that says increase by 5%, the value has been increased by 5%. So if percent is applied, 100% is the normal percent, plus I add 5%. So this should be what? 105%. So the ratio should be 1.05. 105 divided by 100 will be 1.05. If we say that decrease by 20%, your normal percent is 100%, minus 20%, that means you will end up having 80%. So this should be, so R is 0.80. This is applied when the ratio is given through the percentage. And in the question, it can be given through the investment or the interest that can be tested by the examiner.